What's up everybody, welcome to another video. Hope you're ready to flex those brain muscles. In this video we're going to get some practice graphing hyperbolas as well as identifying the center, vertices, foci, asymptotes, all that stuff. So I put two examples into a worksheet and the link to this worksheet can be found in the description below. If you want to follow along or better yet try some of these on your own first and use this video to check your answers, you can do that. I'll have timestamps in the description as well. But before we get into graphing some of these, I want to mention that my videos, hopefully they're helpful to you, but maybe you feel like you need a little extra help. Maybe you feel like you need some one-on-one tutoring, especially since final exams are coming up pretty soon. What I've done for this video is partnered up with a company called ansarimath.com. It's a one-on-one tutoring service, and their tutors are math majors from universities like UC Berkeley, UC Davis, UCLA, so pretty legit universities in my opinion, and they offer one-on-one tutoring online. They have great reviews. They cover topics from basic algebra all the way up to multivariable calculus, and what they're offering is a free session, so you can try it. There's no risk, no commitment. You can try a free session, and then continuing from there, I will say that if you decide to pay for sessions, their prices are very reasonable, probably like a third of what I see other tutoring services charging. So I definitely think this is a great opportunity for anyone who's interested in one-on-one tutoring. Make sure to check out the link in the description below. And now let's go ahead and get back to the video. So instead of just jumping straight into the first example, I want to talk a little bit about our formulas and some general information that we need to sketch the graphs of these hyperbolas. If you already know this stuff, feel free to skip ahead, but we have two general forms that we see the equation of a hyperbola in. In this first form, our first term involves x. In other words, our positive term is the x term, right? In this form, we're going to have a horizontal transverse axis. In other words, the transverse axis is going to be parallel to the x-axis. In our second form, the leading term involves y. In other words, the positive term is the y term, right? In this form, we're going to have a vertical transverse axis. In other words, the transverse axis will be parallel to the y-axis. So that's kind of how I remember it, is that whatever this leading positive term, whatever variable it involves, that is the axis that the transverse axis is going to be parallel to. So you can identify whether we have a horizontal or vertical transverse axis by just looking at the equation of a hyperbola, as long as it's in one of these forms, right? So that's pretty useful because the transverse axis intersects the foci, center, and vertices. So all of these things lie on the transverse axis. We also have a center at HK. And remember, the H follows the X and the K follows the Y, right? So we can find our center, again, by just basically looking at the equation in this form. And now let's talk about what A, B, and C represent. A is the distance from the center to the vertices. B is used to draw a box that helps us determine the oblique asymptotes. This may not make sense. I will explain it through example. I think that's the best way to see this, is just by seeing how I do it in an example. There are general formulas you can use to find the oblique asymptotes. I don't like memorizing. I like to use this method. Maybe you will like it as well. But if you memorize those formulas, you will get the same asymptotes. Our C represents the distance from the center to the foci. And then we have this nice little relationship between A, B, and C. So if we're given an equation in one of these two forms, we can just add the two denominators and take the square root, and that's going to give us C. Hopefully you see why that works out. But this is all the information we need. Using this information, we are going to go ahead and jump into the first example. So the first thing I do is I see what information I can gather by just looking at this equation. And the first thing I notice is that we have a y in our leading term, right? This first positive term involves the y variable. That means that my transverse axis is going to be parallel to the y-axis, and I like to write that as vertical transverse axis, and I'll abbreviate that as TA. Vertical transverse axis. What else can we identify? Well, we can get the center, because the center, well, we can think of this as x minus -3, so that's going to be the first coordinate. And then we have y minus 2. So -3, 2 is going to be the center. -3, 2. What else can we get? Well, we know that a squared is always in the first denominator, right, of this leading term. So a squared is 16 and b squared is 9. And that tells us that a equals 4 and b equals 3, right? I just did the square root of both of these in my head. You could write it out if you need to, but you should end up with a equals 4, b equals 3. And now we can solve for c, because we know that a squared, which is 16, plus b squared, which is 9, equals c squared. So that means that c squared equals 25, and that means that c equals 5. So we know that c equals 5. I'll move this over here. And now what I like to do from there is just go straight to the graph. This is similar to what I did with ellipses, with graphing those. And really with graphing parabolas as well. This is kind of my method. See what information I can gather by just looking at the equation and then go straight to the graph. So my graphing skills, like artist-wise, are not good. If you've watched my videos, you know this by now, just being straight up. So first, I like to go to the center, so we can go here to -3 and then up to 2. And I'll do the center in blue because it's technically not a point on the graph, right? But what we can get from this is, since we have a vertical transverse axis, this vertical dotted line here is going to intersect my center, vertices, and foci, right? And what I do is I draw this dotted line and I use these values of A and C to get my vertices and foci, right? Because A represents the distance from the center to each vertex. So that means if I go up a distance of 4, 1, 2, 3, 4, that's going to give me one vertex. And if I go down a distance of 4, 1, 2, 3, 4, that's going to give me another vertex. So I have my two vertices here, and I can also get my foci doing a similar thing because C represents the distance from the center to each focus. So I just need to go up by one more here and down by one more here, and I can get a focus here and a focus here. So now let's see if I can write those off to the side here. We have vertices, because I think the problem asked us to actually write these out. So vertices at, well, let's see, all of our x coordinates for all these points are going to be -3. Hopefully you see why. They're all on the same vertical line, right? So -3, -2, and -3, let's see, is that 6? Right? Because we subtracted 4 from this and added 4. And that's another way you could do this. You could jump straight from this information to here. I like to go ahead and sketch the graph first and visually see it, but it's up to you. Foci, we're going to basically do a similar thing, except this time we have -3, -3, right? We're going an extra distance of 1 past the each vertex. Hopefully that makes sense. -3, 7. So let's see, we've written out our vertices, foci, center. I think we just need to finish sketching our graph and write out the oblique asymptotes, which I'll show how we find those. Let's see, I want to make sure I give myself plenty of room. So this value of B, remember I said I would kind of show what this gives us through examples. So what I can do with this value of B, let me use the color blue here, is I can go a distance of 3 perpendicular to the transverse axis in both directions. So let me actually complete this axis here. 1, 2, 3. So if I go a distance of 3 in both directions, then what I can do is go up to the focus, right? And down to this focus. And what I'm doing is creating a box. And I kind of talked about this on that first page when I talked about the formulas. And what this box tells me is that one of my oblique asymptotes intersects these 2 points, right? These 2 corners. So I'm going to have an oblique asymptote here. Hopefully I'll see that dotted line. And another one going through the other 2 corners. So another oblique asymptote here. And now what I can do is I can more accurately sketch my graph, right? Because I know that these parabolas are going to sort of tend toward that asymptote. Oh man, let's see if I can do this right. There we go, something like that. They're going to head toward that asymptote, and these are going to do this as well. So again, I warned you, not the best artist. But that is a pretty rough sketch. That's about as good as it's going to get for me. And now all we need to do is write out these oblique asymptotes. And what I do is use point slope formula, right? Which tells us that if we have the slope of a line as well as a point on the line, then we can basically find the equation of that line. And that's exactly what we have here. We have, let's look at each slope. Our rise in this case is the value a, right? We're going up by a and then over by b. So the slope of this line is going to be a over b. The slope of this line is going to be, well, down by a over by b, so negative a over b. And then a point that's on both of these lines is just the center. So if I use this formula here, which is y minus y1 equals m, that's the slope, times x minus x1, then what I end up with is y minus, let's see, the center. So the y value there is 2. And you could use other points, but the center is on both of these. And what this allows me to do is write plus or minus a over b, right? So 4 over 3. X minus, let's see, what is the x1? Well, minus negative 3, so plus 3. Now, depending on what's expected of you, let me go down a little bit, you could expand this out into two different equations. If you did that, it actually wouldn't be too difficult in this case. You would write basically the plus or minus separately in two different equations. You would distribute, and the 3's would cancel here. So in one of them, you'd end up with y minus 2 equals, let's do the positive one first, 4 over 3x plus 4. Then you'd add 2 to both sides. You get y equals 4 thirds x plus 6. And you could do a similar thing with the negative one as well. It would be the same process. I'm not going to do it. Hopefully you know how to, do basic algebra manipulations. For a lot of people, this form is good enough though, especially since this example actually has pretty nice numbers, and the numbers can get even uglier to where you don't have this nice cancellation. So for this example and the next example, I'm actually just going to leave it in this form and leave it up to you and the expectation of your instructor. But I think we have everything we need here. Let's see. We found the center, vertices, foci. The transverse axis, we actually didn't technically write out the equation for it, but since it is a vertical line, it's going to be x equals negative 3. So that's the equation of the transverse axis. Center, vertices, foci, oblique asymptotes we have in this equation here, and we should be good to go. Let's see if we can do the next example. So with this example, you probably noticed that it's not in the form we want it to be in, to be able to just look at it and gather information about it. So we first need to get it into the form we want it to be in, and doing this involves something called completing the square, which we did with parabolas and ellipses. So we should hopefully be kind of comfortable with it by now, and there are many different ways to do it. I'm just going to show the way I like to do it, which is first grouping the x terms together, the y terms together, and then moving the constant to the other side. So we can group the x terms together like so, 2x squared plus 4x, and we can group the y terms together, and that just means I put them next to each other, right? And then I move the 4 to the other side. I always move the constant to the other side. So add 4 to both sides, and I get this. Now, I have to factor out the 2 from these x terms, because in order to properly complete the square, the coefficient of the squared term needs to be 1. So I need to factor out a 2, and what I'm left with is x squared plus 2x, And I'm going to leave a gap there because I want to add something in there so I can factor it, right? And here I'm technically going to factor out a -1 minus y squared minus 4y, and then I'm leaving some room there as well. So this part is a little bit tricky. I had to change this to a negative because I'm bringing this negative out in front. Remember, this coefficient has to be 1, not -1. So I need to bring the negative out in front. So now I need to think about taking half of this, that's 2, squaring it and adding that inside of these parentheses. So I add 1 squared, which is 1. And that means I have to add 1 to this right-hand side? No, it means I have to add 2, right? This is the most common mistake with this part because although we added 1 to this left-hand side of the equation, really we added 2 because it's being multiplied by 2. So we changed the entire value of this left-hand side by 2, so we need to add 2 on this right-hand side as well. Similarly, in here we have half of -4 is -2. Square that, that's 4. So that's what we're adding in here. But really what we did is we subtracted 4 because we have this negative out in front. So I need to then subtract 4 from the right-hand side to balance both sides of the equation. Now when I factor this, it becomes 2 times x plus 1 squared minus y minus 2 squared equals 4 minus 4, those cancel, so we're just left with 2. And now I can just simply divide both sides of the equation by 2. So if I divide both sides by 2, this gets divided by 2, those cancel. This gets divided by 2, this gets divided by 2. And the reason I did that is because I need this right-hand side to be 1, right? So I just divide by whatever this right-hand number is. All right, sorry about that. So once we divide both sides by 2 and simplify, this is the form we get it in, which is exactly where we want it. Now we can start identifying things about the graph. And the first thing we can identify is that the leading term is the x term, and that means that the transverse axis is going to be parallel to the x-axis. So we're going to have a horizontal transverse axis. And the process from here on out, by the way, is pretty much the same as what we did in the first problem. So I really encourage you, if you're trying to learn this, pause this video, try to do all this stuff on your own, sketch the graph, then press play and compare your work with my work. So what else can we identify? Well, the center, that's going to be what? Well, our x coordinate, we could think of this as x minus -1. So we're going to have -1, 2. That's our center. We can also get a and b because a squared equals 1. That means a is 1, right? Square root of 1 is 1. B squared equals 2. That means b is the square root of 2. We can also get c squared because c squared equals a squared plus b squared. That's 3. So that means that c equals √3. I'm going a little bit faster than last example because, again, it's very similar. So now we have some kind of not as nice numbers in this example, but that's okay. We can still deal with it. I think we're ready to draw an x and y axis and start graphing this thing. All right, so let's see. Can I graph my center? That's at -1, 2, and I'm going to do this in blue. Be consistent. What else? Well, we have a horizontal transverse axis. So this dotted line is where my vertices and foci are going to fall on, right? So now I can use the value of a. That represents the distance from the center to the vertex. So that means I'm going a distance of 1. That means I have a vertex here, as well as, let's go a distance of 1 here. C gives me the distance from the center to each focus, right? So √3 is, √4 is 2. √1 is 1. So somewhere between 1 and 2. So I'm just going to go a little bit further out and just approximate that this is, -1. We should go to -1 and we add √3 along the x-axis and then subtract √3. It's going to be a rough sketch. I maybe should have made my my scale a little bit wider because this is going to be kind of crammed in here, but that's okay. Y'all will get the idea from this. Now I can use b, and I can go this time up by root 2, right? And I can draw this box by going up and down by root 2. So let's see, root 2 is slightly bigger than 1. So it's going to be somewhere about here. And then if I draw this here, about there. Actually, I nailed it without even having to draw the dotted lines. And remember, this is going to give us our oblique asymptotes. One of them is going to be here, going through these two diagonals. And the other is going to be here, going through these two diagonals. Hopefully that looks okay. So let's complete our graph, then we're going to write out all the points and the equation of the asymptotes as well. So that's the right side of the hyperbola. Here's the left side. I am the worst at drawing these. I apologize. Hopefully your graph looks a lot better than this. But what we can get is all the information we need. So let's get the focus, or the foci, I should say. And remember, last time my x value was the same for everything. This time my y value is going to be the same because we have a horizontal transverse axis. So my foci, let me actually make a little more room here. For the first x coordinate, I need to do -1 minus root 3, 2. And for the second one, I need to do -1 plus root 3, 2. And you could punch that in a calculator and get an approximation if you want. I'm going to leave it like that. For vertices, I do a similar thing. I do -1 minus 1. That's going to give me -2. So these vertices are going to actually have nice numbers. And then 0, 2. And now let's see if I have room to write out the equation of these oblique asymptotes. So what I want to point out is last time our slope was plus or minus a over b. But now that we have a horizontal transverse axis, that actually changes because now our rise is b and our run is a. So now our slope is going to be plus or minus b over a, which is root 2 over 1. So root 2 is our slope. So we're going to use this point slope form, which is y minus y1 equals m times x minus x1. We're going to use the center, which we already identified up here as -1, 2. So that's what we're going to use as our point. So that's y minus 2 equals, and remember our m this time is b over a. Rise over run, b over a. So root 2 over 1. So plus or minus root 2 times x. What is the x coordinate of our center? -1. So minus -1. And now again, you could do two separate expansions of these depending on what your instructor expects. I'm going to leave it at this for this video. Hopefully this helps. I'm sorry that my drawings aren't the best, and I'm sorry if this video felt a little bit rushed. I do have a final exam tomorrow, so I need to go study for that now. Normally I would do more examples, but hopefully this helps. I wanted to make sure to get this video out because one of my pre-cal classes has a final on Friday. So hopefully you enjoyed this video. We're going to make it through this together. I'm right there with y'all. If you want some one-on-one tutoring, go check out ansarimath.com/braingains. The link is in the description. And keep flexing those brain muscles. I'll see y'all in the next video.